Hello everyone, we are team number 5. So our project title is Pedestrian Detection and a comparison between Mascar CNN and YOLO V7. So means to detect the region of individuals who are present in an environment. Objectives: extracting the features from the real-time video, classifying pedestrians and different vehicles, detection of pedestrians only, and comparing the results of Mascar CNN and YOLO V7. So we have done the literature survey on Mascar CNN and YOLO algorithm. We found a problem with pre-trained models, that is the person sitting on the motorcycle is not a pedestrian, but the pre-trained models detect them as person, so we have to differentiate between a person and a pedestrian. The same problem was inferenced when with the video, so we came up with two methods. One is distance method and the other one is overlap method. So here you can see the distance method, where we calculate the distance between the centers of the two bounding boxes, and according to which we will be classifying pedestrian and non-pedestrian. Same thing goes with the overlap method, where we will be differentiating with respect to the overlap area. So here are some inference on images. This is the output with a pre-trained model, the output with a distance method without normalization. So here you can see the image size is 4000 cross 3000, where the distance measured was 235. Here we had kept the threshold value of the distance as 100, and here is the resized image whose image size is 400 cross 300 and the distance measured was 25. So this distance 25 is less than 100, hence it has clearly differentiated between the person and a pedestrian. Similarly, we have also inferenced with the different camera angle and also the distance between the camera and the object, as you can see here. So these are some outputs of the distance method inferenced using the YOLO V7. Coming to the distance method, we found that normalization of the distance was very much necessary, and hence we came up with a normalization technique. As you can see here, normalized threshold is equal to minimum of image width comma image height into 640 divided by 100. So after normalization, we obtained these outputs. So one is of YOLO V7 and the other one is of Mascar CNN. As you can see, there was some error here. The people beside the motorcycle were not detected as pedestrians, but they were pedestrians. Hence we moved on to the overlap method, where you can see the problem with the distance method has been resolved here. So these are some more outputs of the overlap method, but here you can see that there are some errors in the overlap output of the overlap method. The people behind are detected as pedestrians, but actually they are not. So we thought of combining both the methods. So whenever the motorcycle's height is greater than the motorcycle's width, then we would opt distance method, or else we'll be opting the overlap method. So here is the flow chart, where we'll take the input and then then compute the threshold. Then we'll be extracting the features from the data. So height of bounding box of motorcycle is greater than its width, then we will opting distance method, or else we'll be going with the overlap method. These are some outputs of the mixed method. So the same thing, what we did was we applied the same mixed method to classes like car, bus and truck. Here you can see some examples that the people inside the car have are also been detected as pedestrian person, but they are not actually pedestrians. So by applying the mixed method, we will get this output. Similar result was obtained by the YOLO V7. Now some inference on the distance method, inference on videos using the distance method. Inference on video using the Mascar CNN. Here is the inference on video using the overlap method. This is the output of the combined method. This is another output of the combined method. The same output, similar results were yielded by the YOLO V7 model. You can see the analysis of time and FVS. So here you can see the comparison of YOLO V7 and mask RCNN. Error found in mask RCNN. So mask RCNN was a bit providing bit errors where it is detecting a motorcycle as a person, and also detection of motorcycles is not clear in mask RCNN, whereas in YOLO it is clearly detecting what is person, what is a motorcycle. Error found in YOLO. YOLO model has very less uh, confidence score, and hence it may fail to provide better results. Conclusion. In our project, we work mainly on the detection of pedestrians using mask CNN and YOLO V7. We designed methods to detect only pedestrians, differentiating them from the people driving the vehicles. Then we compared the results of mask CNN and YOLO V7 and found that YOLO V7 performs better than mask CNN. Thank you.